What is the meaning of life?
The question of life's meaning is akin to gazing into the vast, endless cosmos. Each star twinkles with its own story, yet together they paint a grand tapestry of existence.
What happens when you give AI a voice and a body? When it's just not living in a rectangular screen, but is out there, blended into the real world, living amongst us. Just like electricity once lit up the world in the early 1900s, and the internet connected us all in the late 1900s, we're now entering the era of AI, where intelligence is being embedded all around us, into characters, software, robots, and more. And in this tutorial, we're going to embed intelligence into a character called Alien, who's a starborn seeker, witness of the Big Bang, a virtual being who will answer all your existential questions. Oh, and yes, he lives inside visionOS for now. Great, so how are we going to build Alien and bring him to life? Essentially in 3 steps. First, we'll build his brain, then his voice, and then his body. For the brain, we'll use Apple's foundational framework, the on-device LLM. Then we'll give him a voice using Apple's text-to-speech frameworks. And finally, we'll craft his body using a 3D model in USDZ format. And then we'll bring all these 3 parts, brain, voice, and body, into one and connect them all up using MVVM architecture. Because after all, the most powerful creations in our world, both biological and man-made, are built upon simple and elegant architecture. Great, so first we're going to build the brain. For this, we'll be using Apple's foundational model framework, which was introduced in WWDC 2025. This gives developers access to Apple's on-device large language model, or LLM, and that comes with some pretty cool advantages. First of all, inference is free here, unlike OpenAI, where you pay per request, so that's a big thing. And second, because it runs entirely on device, you get better privacy, security, and even offline access. Again, huge things. Obviously, everything comes with a trade-off, and the trade-off here is it won't be as powerful or general purpose as models like GPT-4 because they're hosted in the cloud, benefit from more compute, and just have way more parameters than the on-device model here. The number of parameters is essentially a rough and loose measure of how well or how much the AI could learn. Yeah, so don't expect Apple's LLM model, at least for now, to write novels or debug complex code. Great, so now that you know all the theory, let's dive in and start building Alion's intelligence. So I'm going to create a new Xcode project. So I'm going to click on visionOS, select app, and then click next. I'm going to name it, say, visionOS building Alien. Great, and make sure you select a team, and then make sure the initial scene is set to window and immersive space render set to none. Hit next, and then when you click create, your sample project will be created. Great, so now you got the starting template for this project. Here you got a content view, which displays a sphere and a text below in a window. And this is the view that gets displayed when the app first starts. But for now, I'm going to ignore the view and we're going to focus on building the intelligence first, right? So let's focus on that. Great, so I'm going to create a new folder called models. So name this models. And this is where our business logic would live, right? For example, the AI service that we're about to create now, which will talk to the underlying AI model. So that's Alion's brain. So let's get started creating Alion's brain first. So I'm going to create a new class inside this folder. I'm going to make it a Swift file. And then I'm going to name this LLM service. So large language model service. So this would be essentially Alion's brain. And here we'll import the foundation model framework. Again, this is the framework that gives us access to the underlying AI model. And now I'm going to create a new class called this LLM service. And here we'll first have this constructor, which expects a language model session. This is the core API that we'll use for creating this LLM service. And then we'll have a function called response. So this function, if I just collapse it, here we'll take and put the user's prompt as a string. And then we'll output the AI model's output to that prompt as a string. So this is all text-based. The prompt comes in as a text, and the output from the AI model comes in as a text as well. So inside here, if we expand it, what we're doing is first we're checking if the session, i.e. this language model session, again, the core API that we're using, we're checking if that is currently responding to a prompt. If it is, we'll return nil because we don't want to do anything. We want to wait for that to finish, right? So if this function is called and the session is currently responding, we'll return nil. So we will exit immediately. But if the session's not busy, what we'll do is we will use the session's respond method, which lets you respond to a certain text prompt. And here we'll pass in the prompt from the user. So here what this guy does is the session would respond to the user's prompt and store it in this response variable. And here we got await because this is an asynchronous method, because again, it could take a while for the session to process and respond to the user's input. Great. So this is the core bit really, where we respond to the prompt using this session.respond method. And the response object that you get back, it has a content here. So if I go here, you can see a response.content, and this is a string which gives you the AI model's response as a string, and we return that. Great. So simply this function, when it's called, it would take as input the user's prompt and return to us the AI model's output as a string. So this is all you need really to create Alion's intelligence. You create this class using a language model session, and then we call this response function to respond to the user's prompt, and the Alion's intelligence is all embedded within this method, right? Now we're going to test this out. So what I'm going to do is I'm going to go here to the content view. Here at the moment, we got a vertical stack that displays a 3D model first, the sphere, and then a text after, right here, hello world. I'm going to get rid of all of that, and I'm going to replace this with an empty view. This displays nothing, just to simplify things. And here in the on up here, so this is code that gets executed when the view first appears, when the app first starts. So here for the on up here method, here what I'm going to do is I'm going to call the model that we just created and insert a hard-coded prompt into it. And then we're going to print the output to the console so that we can see what the output of the model is. So here for that, first I'm going to initiate a LLM service, the AI model class that we just created here that contains Alion's brain. So here I'm going to say let service equals LLM service. And here we need to pass in a language model session to this class. For that, you can just call init here, init like that. This simply constructs the language model session inline. So that's just a shorthand way of doing it. Now we get an error saying you need to import foundation models. So here I'm going to click apply, and that simply imports the foundation model frameworks. And that's needed because here we're initializing a language model session, right? And that relies on the foundation model framework. Great. So here we just constructed the class that we just created, and we passed in a language model session using this guy here. Great. So now this service is constructed. Now we can call the response method, which essentially gets the output from the prompt. So here now in the onAppear method, we're going to do let response. This would be a string. And we're going to do service.response to the prompt. The prompt, let's hard code it to, let's say, who are you? And let's see what Alion answers to that. And here we're going to say this is an async call. Remember, this function that we just created was an asynchronous function. And the error is saying essentially this is not inside an asynchronous context at the moment. This onAppear method is synchronous. So what we need to do is copy this, and then instead of onAppear, we're going to use this task modifier. This adds an asynchronous task to perform before this view appears. That's what we want. And here we're going to paste in that code that we had earlier. Asynchronous call is inside an asynchronous context. That's great. The last thing we need to do is prefix it with await. Great. So that's all working now. Again, all we did was we put the call inside an asynchronous context, and we marked it with await because this is an asynchronous function. So you need to await it. In other words, wait for this method to complete. And after that, we're simply going to print out the response. So we're going to say print. You can just do a print and then response. And this is an optional. So if there's no response, we're going to say no response received. Great. So now all the compile time errors should be gone. Great. So all we did was initialize the class we created, and using the task modifier, this essentially runs some asynchronous code before the view first appears. And in here, we pass in the prompt and wait for the response from the service. And then when we get the response, we print it out here. That's all we're doing. Awesome. So now let's build this on the simulator and see what we get. Awesome. So now you can see the app is installing, launching. Great. So when the app first launches, an empty window appears because obviously we passed in an empty view, so there's nothing displayed. So that's correct. And now in our console, we should have a print statement. But the print statement says, I'm sorry, but I can't assist with that. Great. So that actually shows that Alion's working. So here we got some interesting finding, and we found out that Alion, the LLM service, when you ask it, who are you? It does not give a response, possibly something that's internally programmed inside the model, Maybe Apple does not want it to answer such questions. That's quite interesting, isn't it? I didn't expect that, to be honest, because I'm doing this live. Great, so I'm just going to quickly try this again, but with a different prompt. Ask it something more generic. Let's say, what is the meaning of life? Obviously, that's very generic, isn't it? Great, so let's try building this out and try again and see what we get. And once again, it's installing, and let's see what Elion's gonna say this time. Great, so now we got some interesting output. This is what Elion has to say. The meaning of life is a question that has been explored and debated by philosophers, theologians, scientists, and individuals throughout history. Blah, 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 blah. You can read it. But now you can see it has given us some solid output, right? It's pretty generic. It's pretty diplomatic. It's not got much personality in it. And that's because at the moment, we've not given Elion a personality yet. So when we created Elion's brain inside here, LLM service, we simply create the service with a session, and then we simply use this session to respond to the prompt. There's nothing telling Elion yet what personality it should have. So next step, that's exactly what we're going to do before giving him a voice. We're going to give him some personality. And how do you do that? That's exactly what an instruction file is for. What we're going to do is when we create this language model session, there's an option to pass in some instructions which defines Elion's personality and all the constraints it must have. So that's how we give Elion a personality. If you use other vendors like say Microsoft's GitHub Copilot, there's the same concept of an instruction file, although it's a bit more complicated to set up there. But the concept is same, right? The instruction file, when it comes to LLMs, is what the LLM first listens to before listening to the user's prompt. If you think of the human brain, there's the subconscious and the conscious, right? The subconscious is more internal and more default and it's more embedded, right? Again, to simplify things massively. And the conscious is the layer over it, which we daily engage with. So you can think of this instruction file as the subconscious, right? It's the personality, it's the default behavior. It's what the LLM first listens to before listening to the conscious side, which is the user's prompt, right? So you can think of it like that. Great, so to give Elion some personality, we're gonna add in some instructions for Elion to follow. So for that, I'm gonna go back to content view. And here, when we're creating the LLM service, and this session, we're just using the default constructor. Now you can see when we create a language model session, we got different options. We got model, guardrails, tools, and I won't go into all of that, but what we're interested in is this guy here. We're creating the model with some instructions. This is a set of instruction files that you can provide Elion with. So here, what we can do is simply pass in some instructions as a string. Some string that will define the instruction or the personality of Elion and additional constraints that we want to add. So let's go create that instruction file here. Obviously, the instruction string is going to be long, so we don't want to add it inline here. Instead, we'll create an extension to strings. So we're going to extend the strings class. So extension, and we're going to create a static var. So var, would be a computed property. So we're going to say model instructions. We're going to name it such. And then I'm going to paste in Elion's instructions. Oh, sorry, I forgot to say extension string. Great, so here we're extending the string class with the model instruction var, and that var constrains the string which contains Elion's instructions. Here I've just copy pasted the instructions I had created, but broadly speaking, you can see this divided into 4 headings, right? First, we described Elion's role, and then we describe Elion's purpose, and then we describe Elion's tone and style, how he should answer questions. And then we need to provide some guardrails as well. This is a good practice when it comes to prompt engineering. Where we make instruction files, we need to define some guardrails, or what you often call negative prompts. We basically tell the LLM what not to do. So all the above is what to do. And here we're defining what not to do, because that will give the LLM more context and more constraints, and it's more defined. And as we all know, LLMs perform better when the task defined is precise, concise, and has all the context it needs. So we're providing plenty of context here. We're describing the role, the purpose, and the tone and style, how it should speak, what it should not do. And then finally, we give it some example, like sample question and answers, just so it is more clear how it should answer questions. I think the structure is generally good practice. The more directions you give, the more it can follow that. This is the beauty about LLMs, right? All the big vendors, OpenAI, Apple, Microsoft, they all give generic models, But using certain prompt engineering techniques, you can tailor it to your specific needs by providing it more context, more instructions, and more guardrails and such. Great. So for the role, I've told it that you are a mystical astronaut, a gentle, wise traveler who has wandered the galaxies in search of truth. You have seen stars born and fade, and you can read the rest. Basically, just tell the model who it is. And the purpose, we tell the model why it exists. It exists to act as a philosophical guide for the user. Finally, we give it a tone and style, how it should answer. So we're saying make your answers concise, don't go on for too long, because you can see the generic response is pretty long, right? And then we say speak with poetic awe and reverence, like a blend of space captain, philosopher, and storyteller. Again, we're adding some personality here. Use cosmic metaphors, invite rather than instruct, encourage virtue. Great, so here we're giving it some personality. And then finally, we have some safety instructions. Do not provide advice that replaces professional support. In response to emotionally vulnerable questions, speak with care and hope. Do not condemn, exclude, or moralize. Again, we're telling it what not to do. This is very important, especially when you're creating public-facing LLMs. We give it some guardrails so that it does not cross certain boundaries. And finally, we give it some examples just so it knows how to answer questions. Great, so that's all embedded in the instruction file. And now here, when we're creating this class as the instructions, we're just going to pass in that instruction. So I'm going to do string, and we got the extended property that we just created. So that is model instructions. Awesome. So now we're creating the LLM class with the session with some instructions so that it has some personality now. It knows who it is, it has the purpose, it has the tone and style it should respond with, and we finally have some examples to follow. Now let's compare what the output is. Is it as generic as before, or is it something a bit more interesting? Great, so now it has launched the app, and let's see what the output is. Do you see that? It's a little more concise, and it has much more personality in the response. It's saying, the eternal question of the cosmic traveler. Imagine life as a vast galaxy, each star a unique journey, each planet a story unfolding in the universe's grand tapestry. The meaning of life is like the light that guides a traveler to the darkest nebulae, a whisper of hope carried on the wind of eternity. Do you see that? Just by adding the instruction file, it has some personality now. It's speaking more like a poetic philosopher that has seen the stars and the beginnings of the universe, and it's exactly what we defined in the instruction file. Great, so here we have it. We've essentially created Elion's brain, and it's very simple but very nuanced at the same time, because it all depends on how well you construct the instruction file. There's no black and white answers. It's more art than science, really, when it comes to prompt engineering. And now we'll move on to giving Elion a voice. Right now you can see Elion speaking out through text, and it's dying to utter words just like a newborn baby, right? It's got all the ideas in its head and it just can't wait to speak, but it just doesn't know how. So let's give him a voice. Now, before going any further, I want to show you something. So when I started my spatial computing journey, I wish there was a single place for everything Apple related. That's why I created realityuni.com. It's a beginner-friendly platform to help you learn, explore, and start building for the world of visionOS. So if that sounds like you, definitely check it out. So now before we go on to building Elion's voice, let's ask ourselves why do this, right? Most of today's AI interactions, whether with ChatGPT, Claude, or others, are still text-based. But something truly profound happens when AI speaks. It's a 1000x leap in presence. Suddenly, it doesn't just feel like you're chatting with a tool, it feels like someone is there with you. And that's the key. Voice has always been our most natural way of communicating with intelligence. So that's why we're giving Elion a voice. And to do that, we'll use a native Apple framework called AV Speech Synthesizer. It's part of Apple's AV Foundation framework. And this gives us a straightforward text-to-speech engine. Now, fair warning, the voices available today are still pretty synthetic, so they can sound a bit robotic. Hopefully future updates will break it more realistic and give it more emotional range. But for now, this is enough to give a sense of presence, and that's what we're after. So let's dive in. Great, so now I'm going to go back to Xcode, and here under models, so far we got Elion's brain, right? The LLM service. So just like we created the service class for the brain, the LLM service, now we're going to create a new service class for the voice. I'm going to name that text-to-speech service. Under the model folder, you can do Command N to create a new file. Then click on Swift file, make sure visionOS is selected here, and then click Next. and then you can name this text to speech service. Great, so now here, this class would be responsible for the conversion of the text that we get from the LLM into speech. And for that, we'll use Apple's AV Foundation framework, and more specifically, AV Speech Synthesizer to essentially synthesize speech out of text. Great, so first, let's just import AV Foundation here. And here, I'm gonna name this class text to speech service. We're gonna give this a synthesizer property. So this would be an AV speech synthesizer, the main API we'll use. And then when we construct this class, we want to pass in an instance of a speech synthesizer like that. And then we're going to have a function called speak. So this function would simply take as input a text and then will output a speech, right? And then in here, we'll write some code to convert that text into speech. So here now, we got a couple of things we need to do. First, we need to take this text and filter it and clean it up a bit. And I'll tell you what I mean by that soon. And once we've cleaned the text up a bit, we're gonna create a speech utterance, which would essentially define what voice we want and the rate and the pitch and the characteristics of the speech. And then finally, once we've got the filtered text and the characteristics defined, we will use the synthesizer guy here to speak out the text. Great, so let's see what that looks like now. So for filtering text, the main idea is that you want the text output that's coming out from the AI to essentially be ready for the speech framework to use, right? So at the moment, the speech synthesizer guy is not smart enough to differentiate between like special characters or colons or stuff. For example, if it encounters a colon in the text, it would literally speak out colon and blah, 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 right? So that would sound odd in the middle of a speech. So we want to filter out things like that. I'm not going to bore you with all the details. Instead, I'm going to simply copy paste an extension to string here. So here I've extended the string class with a computed property called cleanup for speech. And what this guy would do is it loops through the current string. For example, if this string is hello, it will loop through each letter in hello. So HELLO. And then it would execute some code and would filter out each letter with these conditions, right? So what it would do here is if it's a colon or a dash, it would replace that with a comma. So for example, if it's hello colon, my name is Nikhil, it would filter out the colon and then replace that with a comma. So it'll be hello comma, my name is Nikhil. Because if it's hello colon, my name is Nikhil, the output from the audio framework would sound like hello colon, my name is Nikhil. But if it's hello comma, my name is Nikhil, it would sound more natural. It will be, hello, my name is Nikhil. It won't explicitly speak out the comma. Again, this is something I found with experimenting with the framework, so you can try it out yourself and see what happens, and maybe in future updates this might get sorted. But anyways, so this bit, it replaces colon and dash with a comma, and then it looks if the current character is a letter, or a number, or is a white space, or is a comma, or is a dot, or is an apostrophe. So if it's any of these, we will pass them through and append it to our new string guy here. These are all the things that we include, right? Letters, numbers, white space, commas, dot, and apostrophe. I found through trial and error that these are the bits that actually work as expected in the audio framework. These guys don't, so that's why I replaced it with a comma. And then finally, all other characters, special characters or whatnot, they would be skipped or removed. Great, so that's what goes on inside this for loop. It loops through each of the string, whatever the string is, and then it applies this logic to filter out and clean it and essentially just give us the letters and characters that works well. So here, all I need to do is say let filtered text equals text dot cleanup for speech. Again, this is the computed var that we added as an extension to this. We simply loops through the string, whatever the text is, and then cleans it up and returns us a new string, which is the cleaned up string that is ready for the speech framework to use. So again, this converts raw string into cleaned string. Again, that might be wrong English, but you get the point. Great, so that's the filtering logic. Now, after we've filtered it, next up, what we want to do is define the characteristic of the audio, right? For that, we're going to use this guy called AV speech utterance. So I'm going to create an utterance. So utterance equals a speech utterance. Again, this is an API which can take in a string and it creates an utterance with the text string that you specify for the speech synthesizer to speak. So this is the text that we wanted to speak. So I'm going to pass in that text. Oops, not that text, but the cleaned up text. So the filtered text, I'm going to pass that in here. And then finally, we can define the characteristics of the utterance. So utterance dot, you can see there's a pitch multiplier, the rate of speech, the voice and volume. You can fine tune all kinds of characteristics here. For now, I'm going to play with the pitch multiplier. So I'm going to give it a pretty low pitch, so it will sound more serious. And then the rate, I'm going to make it pretty slow. Start rate. This is the rate at which the AI would talk. I'm going to make it 0.53. Again, these are values I fine-tuned and play with. You can try your own. And then finally, we need a voice, right? So we can give the utterance.voice, this guy here, and give it a AV speech synthesized voice. This is the voice the speech synthesizer uses when speaking the utterance. So we can give it a certain kind of voice. And unfortunately, we don't get like a plethora of different options to choose here. And the choices we do get that's given to us by Apple is pretty robotic and synthetic and not very natural and lacks emotional range, at least from what I've found. But that's what we have now, so we gotta work with it. So AV speech synthesis voice, and this should have a speech voices method, which gives us an array of voices, speech synthesis voice. Again, this retrieves all available voices on the device. And then I'm gonna filter for the ones where the voice is a novelty voice. So I'm going to filter on that, and then I'm going to check if the voice, the voice trait, is the novelty voice. I think we got an extra bracket here, so that's why that's throwing an error. And then we also see this error because here we've not assigned any voices yet. So I'm just going to comment this guy out for now. And here what we're trying to do at the moment is just get a list of all the voices that's available to the system. And then if you want, you can print these voices out by doing a print statement as AI suggested. Available voices, take these voices and map it to the voice name. So it will literally print out all the available voice names. So if you run this, you'll see what all the available voices are, but I'm not going to do that. But you have to trust me, there's a voice called Superstar, and that's what we're going to use. So what I can do here is to retrieve the exact voice. I can do let Superstar voice equal voices.filter. Again, here what we're doing is we're filtering these voices and we're looking for the one where the name equals Superstar, like that. And then if there's such a voice, it would store that in this variable, Superstar voice. Great, so simple as that. So here what we're doing is this bit of code is literally to retrieve the voice that we want. Again, to make this cleaner, you could probably put this inside a computed bar. So we can copy that and just go over here and create a new computed bar here, call this Superstar voice. And this would be an AV speech synthesis voice, like that. And it would be an optional because maybe that might not exist in the system. And we're going to copy paste that code we just had before. And then in the end, we're going to return the Superstar voice. So here it's saying cannot return expression of type an array of voices to return type synthesized voice. So what that's saying is here we're saying, hey, we're expecting a single voice, but here we're actually returning an array of voices. That's because here what we're doing is we're taking in this array of voices, this guy here, filtering and looking for all the voices with the name Superstar. And this in turn would be an array, right? Because it would be all the voices that have the name Superstar. If you option click here, you can see the type. It would be an array of synthesis voice. We just want the Superstar voice. And we know that there's only one Superstar voice. So what we can do is simply get the first element and trust that's the Superstar voice, right? So we can do dot first here. This is the first element of the collection. So it would return us the Superstar voice instead of an array. Great. So now if you command click here, you can see this is just one value. It's not a collection. Great. So that's what we expect. Great. So what happens is when we call this guy here, it's a computed property. It would return us the exact voice that we want to use. So now I can get rid of this code, which does pretty much that. And here, where we're defining the speech utterance and the characteristics, we can now have the voice. Again, for a reminder, the voice is the AV speech synthesis voice, which is again what this guy returns. So I'm going to say let voice equals Superstar voice. Great, so that's the speech utterance defined. Again, to recap, we got a filtered text where we clean up the speech, and we pass that filtered text here, and we define the characteristics of the speech here, the pitch, the rate, and the voice that we want to use. For now, we're using the Superstar voice, which uses this guy here that's given to us by the system. Now that we got all that ready, now we can simply speak, right? So for that, we're going to again use the main API here, the synthesizer guy here, which gets passed in when this class is constructed. So we can do synthesizer, and you can see there's a method called speak, and that expects as input a speech utterance that it could speak on. And this utterance is exactly what we created here. Here we created an utterance with the text, and we gave that utterance specific characteristics. Now we can simply speak out that utterance over here by passing that here. And this is what essentially gets the audio engine to convert that text into speech using the superstar voice. Great, so that's the speak function ready, and that should all work now. Great, so now what we can do is from an outside class, we can simply call the speak function and pass in a text here. That text will be converted to audio. So now what we can do is we can test this out and see if the speech service is working by going back to the content view. And previously we used this task modifier, which gets called before the view is displayed to test out the LLM service. Now we're going to get rid of this because we finished testing the LLM service and we're happy with it. Now instead of this, we're going to test the text-to-speech service. So we're going to test Elon's voice now. So for that, again, I'm going to get rid of this guy here. We'll come to use this later, don't worry. But now I'm going to use text-to-speech service, speech service, and this would be the text-to-speech service, the class that we just created. And the synthesizer is an AV speech synthesizer. So you need to make sure you have AV foundation imported here, this guy. And then you can just call init here to initialize an instance of AV speech synthesizer. Obviously, this is just a shorthanded way of doing the same thing. So like that, AV speech synthesizer, how you create objects. In Swift, this is just a shorthand way of doing the same thing. Great, so we got the speech service initialized here, Elon's voice. Now we can test this out. So here, this time we don't need a task because if I go to speech service, the speak method, if I go to this guy here, the speak method is not asynchronous, right? It's a synchronous task. So there's no async here. So we don't need to, going back here, we don't need to have a task modifier here. Instead, we can use the onAppear modifier, which again is the same thing. The code here gets executed when the view first appears. And here, what we're going to do is we're going to use the speech service that we just created, text-to-speech service dot speak, and we're going to pass in a dummy text. I hope AI will help me here. Great. There you go. Here, essentially what I'm doing is I'm passing this text to the service, and this function should convert this text into audio. So let's see if that's working. So here we're simply testing the speech service. So I'm going to click build and run, and let's see what we get.
Hi there, I am Elon, your mystical astronaut guide. I have wandered the galaxies in search of truth and wisdom. How can I assist you today?
Awesome, so that sounds pretty decent. We got the text that was passed here. Hi there, I'm Elon, blah, blah, blah. It's being converted to audio pretty well. I like the tone. It's a bit childish, but again, that comes with the nature of this superstar voice that we chose. You can try out the different available voices here and try out different stuff and play around with it. But I'm happy with the voice characteristics as well. The voice, the rate, the pitch, I made it low intentionally, so it would sound a bit more deeper. If you set it to the original value, it would simply be too high and too childish. That's why I brought the pitch down a bit. Made the rate slow just to give it that poetic, philosophical vibe. Great. Awesome. So that's the speech synthesizer working now. And it's all wrapped up in this nice service class. Great. So we got the brain, the LLM service, and we got the speech, which converts text into audio. So we got the two fundamental pieces, the brain and the voice, ready. Now what we don't have yet is Elon's physical form, right? Like the body. We got the brain, the voice, but no body yet. So now we'll work on that. Simply put, it just means getting a nice 3D model that represents the spirit of Elon. I went with the cosmonaut and I used a tool called meshy.ai to make it. It's essentially an AI tool that lets you create 3D models using prompts. And the nice thing about it is that you can convert and export it as a USD file, which really helps because that's what's supported with Apple Vision frameworks. You need USDZ file. So that's the tool I used, but I won't bore you with the details. What I'm going to do is I'm simply going to attach the model that I used with this video. So the first thing you want to do is you want to download the models that I've attached with this file. So you'll notice there's 3 models that I've attached. One's called Elon Idol, and then Elion talking, and then Elion thinking. So these are the same models, but the difference is each model has a different animation attached with it. So at the moment from Meshy, I couldn't find a way of embedding multiple animations in a single model. That's why I exported like 3 different models, each containing one single animation. And then in the Apple side, we'll combine them into one, so don't worry. It's just the same model, but each export containing a different animation. So make sure you download those 3 files, and then let's go back to our project. And then here, if you go under Reality Kit content and then open package, here you can see open in Reality Composer Pro. So click that, and that should take us to Reality Composer Pro. Great. So the Reality Composer Pro, if you don't know, is a no-code tool provided by Apple where you can essentially design your 3D experiences. We're going to get rid of the sphere that comes by default. And then I'm going to get rid of the material as well. And then we can go to our project browser here. This is where we have listed all the assets we have. So currently we got materials and scene.usda. So this scene.usda we want to keep. And if you hit save, that should save. And now you can see the scene.usda file. It doesn't show the sphere preview anymore because this is the USDA file that describes our scene. And because we deleted the sphere, that's gone from there in the preview. Awesome. So here what we're going to do is in the project browser, we're going to import the 3 models that we just downloaded. So I'm going to click on this guy here, and then I'm going to go to the location where I downloaded my models. So I'm going to drag all those 3 models and then import them here. Awesome. So now you can see we got 3 different models imported. I'm going to get rid of the 2 other models. I'm just going to keep 1 model, and let's just rename that to Elion. So this is Elion. And here you can see there's an awkward rotation. So I'm going to fix that. I'm going to rotate it along the x-axis by 90 degrees. Great. So that looks better now. Great. So now that's the model, right? That's the astronaut that we're going to work with. And now what I'm going to do is I'm going to see how we can fix the animation guy here. So here I'm going to click on add component, and you can see there's this guy called animation library. And here this would contain all the animations that Elon could have. And here, if I click on add, you can see I can add animations from different models. So first I'm going to click on the Elon idle. This would essentially get the animation contained within this file and import it here. So I'm going to click on select, and now you can see the Elon idle animation is imported. If I click on that and click play, you can see what that would look like. Great. So you can see the idle animation, right? That's pretty good. Now, similarly, I'm going to add in the next animation, and that would be the animation that's embedded within this model, Elion talking. That would be the talking animation. So I'm going to click select there, and let's see what talking looks like. If I click on talking, like you can see, that's what Elon would look like when he's talking. Awesome, not bad, right? Again, remember, this is all created using the Meshy AI tool, so you can try it out if you want. Obviously, this is not sponsored by Meshy in any way. I'm not affiliated with them. I'm just mentioning it simply because I've used it. Great. Now, finally, we'll get the Elion thinking animation. What does he look like when he's thinking? So click on select, and then let's see what that would do. Great. So that's how it would look like when he's thinking. So when he's idle, talking, and thinking, we got all those animations imported and embedded in this one single model. Great. So that's good. We got one single model with 3 animations embedded. Awesome. Now make sure you hit Command S. Always make sure you click in Reality Composer Pro for the changes to take effect. So hit save, and now we got the 3D model more or less ready. Now I want to show you one last thing here. If you go to statistics here in this tab, and you can see this gives you the statistics of our scene, right? Now if I look on geometry, it will show you the triangles and vertices that makes up this model. Triangles are essentially the building blocks of the 3D model. This model that you see, the mesh that you see, is made up of 10,000 triangles. That's what this is saying. So the higher the number of triangles, it would have more realistic look. But the drawback of that is the higher the triangle count, the more expensive it is to render it. So the higher, the better looking, but the more expensive it is. So the less performant it might be. But the lower the triangle count, the less realistic it would be. But at the same time, it's cheaper to compute, meaning your experience will be smoother. It's a trade-off really. So you just play around with what you want. But I typically aim for about 10 to 30K. Awesome, with that out of the way, now we got Elion's body with all the animations, and we got Elion's brain and his voice. We got all the different pieces ready, and now it's time to combine them all together into one. And we'll start by importing Elion's body into our scene. So make sure you click save and let's go back to Xcode. Great, so now if we go back to Xcode, if I click on package, you can see we got a new body here, right? Because we just replace the sphere with Elion. Awesome, so now we're gonna write some code to essentially here import the model that we have of Elion and then show it in the scene. So let's do that next. Great, so now I'm gonna get rid of all this text-speech service code because that was just to test out the text-to-speech service. We already did that. And now we're dealing with the body, right? Great, so what I'm gonna do is I'm gonna use this thing called a reality view. So reality view is what you use to display 3D scenes. This content guy here contains a list of all the entities in your scene, and everything in RealityKit is an entity. So everything in your scene, including visible bits like 3D models or invisible bits like audio, they're all entities and they're all contained within this content guy here. So anytime you want to add a new 3D model to the scene, you would add it to this content and it will get displayed in the scene. And this closure is the make closure. It's what gets called when the reality view first appears. For now, in the make closure, what we want to do is load the model and then play a default animation, maybe the idle animation as a default one. So let's do that first. So to load the model, there is a function, that's a static function with entity called load. This loads a model with a specific name from a bundle, right? So our bundle is this guy here, the RealityKit content bundle. And in there, if you go to assets, you'll see there's this scene guy here, right? This scene, if you go back to our Reality Composer Pro, is this guy here. Or if you go to the project browser, you can see there's something called scene.usda. So this is the main scene file, and that's what's shown here. So what we want to do is load this guy here, the scene.usda, and from within that, then load the Elion model. So first, what we want to do is essentially load the scene guy here from this bundle. And to do that, if I go back to the content view, you can see there's this entity.load function, which lets you load an entity, the scene.usda entity, from a specific bundle. And in our case, it's the RealityKit content bundle. So to do that, all we got to do is simply say named and then scene. So this guy here, which is a scene, and then that would be in the RealityKit content bundle. Great. That's all you got to do. And then this one will store it in a variable called scene. And then from here, we can find an entity. We can do scene.find entity. And this recursively searches all descendant entities for one with a given name. And the entity that we're looking for within scene is this guy here, right? Elion. So scene, and then within that, Elion. So the name here would be Elyon. Great, so that's basically the gist of it. But here we're getting some error. Let's see what that is. So that's called named, not name. This call can throw, so it can throw an error. So we need to mark it with try and then wrap it inside a catch statement. So do this, and if there's an error, catch it here. And for now, we'll just throw a fatal error because this is prototype code, but in reality, you might want to handle it more gracefully. So failed to load scene, error dot, that looks good. Great. So now let's store that here. So let Elion equal scene.find entity. That looks great. So all this guy does is it looks for the scene, and from the scene, it loads Elion. And that's the entity that we want to display in this content guy here. So content.add entity. So this adds a new entity to the scene and in a sense display it there. This guy here, Elion. So here what we're doing is loading the scene, from that finding Elion, and then adding Elion to the content guy here, which displays all the scenes in reality view. At this point, we also need to unwrap this. So because that's an optional, so we'll do guard let else, again, throw a fatal error. Elion not found in scene. So here we're loading Elion, and if Elion's not found, we'll crash by throwing a fatal error. Great, so scene, from scene find Elion and add Elion to the reality view content, which in a sense would display Elion in the 3D scene. That's all you need to essentially display Elion's body or his model in a reality view. Great, so we can do it like this, but I'm going to make it a bit more cleaner because this reality view will get messy with a lot of code later. So I'm going to take all this code, actually get rid of this adding to the scene bit, instead take all this code, which essentially loads Elion from the scene and the package. Instead, I'm going to create an extension to entity. So extension entity, and then I'm going to create a static function here called static load model from RCP. RCP stands for Reality Composer Pro. And we want to load a model with a specific name. So the name would be of type string, and then we want to return an entity. Or you can do self here instead of entity because we're extending entity, right? So it's the same thing. Load self, return self. And then we'll copy paste the code that we had before here. So it would first load the scene, and then from scene, it will look for an entity with a specific name. And here we want to pass in the name that we pass here to the function parameter. So instead of hard coding Ilion here, we want to pass in name here. This would make it more reusable and generic. So we can use it for other models apart from Ilion as well. That's contained in the scene. Great. So here we're loading scene. From scene, we're loading the model that we want. And then, so we rename that to model. And then finally, we can return that model. Return model. Great. Actually, cannot convert return expression of type entity, that's correct, to return type self. Actually, I don't know why that's showing that, so I'm just going to rename this to entity. So return type is explicitly entity now, and that error is gone. Great, so now if I collapse this function, essentially, if you pass in a name of a model that we want to load from the scene here, with the name scene, so it would return to us that model in the form of an entity. That's exactly what we want. So now going back to the reality view, we can simply call that function in a much neater way. So here we can say, let alien entity equals entity dot load model from RCP. And the name of the model that we want to load is Ilion. So ELYON. So ELYON. Great. That reads a lot better, right? We're loading the Ilion entity from the scene. Great. And now once we've loaded it, we can add it to the content guy here, content.add. So actually just name it Ilion. I don't want to confuse you all. So Ilion. Now add that to the scene. So we load Ilion here and add it to the scene. This is all you need to display Ilion. Great. So now we got Ilion loaded, but that's just not what we want. We also want to play a default animation, right? When the Ilion first loads, we want him to play the idle animation. If I go back to the Reality Composer Pro project, this guy here, and if I click on Ilion and go to the animation library, which again contains all the list of animations available with this model. If you click on the idle one, you can see this animation, right? That's exactly what we want to play. So for that, let's go back. Instead of doing that all here, again, to make it clean, I'm going to create a new static method in this extension to entity. Static func play animation. And the animation here would have a name. So we'll take in a name. So that would be the name of the animation. And then we will write code here for playing that animation with a specific name on the entity. So the entity would contain certain animations that's contained within the animation library component. And then we'll essentially retrieve that from the entity and then look for the animation with a specific name and then play it on the entity. So we'll write code for all of that here. So here first we want to retrieve the animation library from the entity, and then we want to look for the animation in the library with the specific name, and then we will play that animation on the entity. Now let's first retrieve the animation library. So let library equals self, so the entity, and get all the components of the entity because animation library is a component. So self.components, and I think this can't be a static function, right? Because can it be? I don't know. Yeah, instance member components cannot be used on type entity. So this can't be a static function. So I'm going to remove static here. Great, that works better. So again, self, the entity, and look for the components list. So this is all the components of the entity. And then look for a specific component named animation library component. Animation library component dot self. This would give us the animation library, which again, if you go back to Reality Composer Pro, is essentially this component, which contains all these animations. So here, going back, we got the animation library in code here. And from here, we want to look for the animation with the specific name. So if you pass an alien idle here, it would look for that from that library. So here, what I'm going to do is anim library, and then look for animations, this guy here. This is a collection of animations on the entity can play. And then from this one, I'm going to look for the animation with this specific name. And then once I found that animation with a specific name, I also want to make sure I repeat it. So repeat as in, I set the repeat duration to infinity. This will ensure that the animation would be configured to play indefinitely. Great, so now that's there. I'm gonna store this inside animation. Great, so this looks for this animation with a specific name from the library and configures it so that it will play indefinitely using this guy here. Great, so that's animation. And now you can see this is an optional. If you hover over it, this is an optional. You can see with a question mark, so we need to unwrap it as well. So we're gonna do guard let animation. If that animation exists, great. If it doesn't, let's throw a fatal error again. Throwing fatal error is really bad practice in production code, but here, because this is prototype code, I'm not worrying about error handling too much. So yeah, just tap on that. Animation named name, this name not found in the library. Great, so that gives us the animation. Now to play the animation, we can do simply the entity, i.e. self, which is the entity, has a method called play animation. This guy here displays the animation with a given name. So for play animation, we will need to pass in an animation resource. So you can see if you hover over it, this is an animation resource that we loaded from the library. So we can pass that here, animation, and the transition duration, we're gonna set that to 2 seconds, and start pause, we're not gonna use that. Great. So that's simply how you play the animation on the entity. So this method, we're getting the library. From the library, we're looking for the animation with a specific name, and then we're simply playing that animation on the entity. So all you got to do is pass the name of the animation you want to play with this function, and it would play it. So now we can use it back here. In the reality view, we load Eleon. This is in model entity, and then we add it to the scene. And after we add it to the scene, we can also play animation. So what we can do is Eleon, which is an entity. You can see it's an entity. So we just added an extension to the entity called play animation. This is the function that we created and it's extension to entity. So we can call that here. And the animation that we want to play, make sure you pass in the exact name. So the name here would be Eleon idle. So I'm just going to copy that name and then pass that here. So this would play the Eleon idle animation on this entity, Eleon. Great. So that's all the code to load Eleon, display it in the scene, and play an animation. Very simple, very readable, nice and neat. Now before we play this and test this out, we need to do one more thing. So if I go to the starting point of the app, which is named after the project name of your app, so this guy here, and it's also marked with this main thing here. So this is the starting point. You can see the starting point would display a window, and inside the window, we display the content view that contains all the reality view and all the 3D scene stuff. But this is not what we want. So in visionOS, you can display content inside a window, volume, or an immersive space, right? So windows is mostly for 2D content, and volumes is where you display 3D content and 3D scenes also. In immersive space, you can display both volumes and windows, and you do not have to share your space with other apps. So what I'm gonna do here is instead of a window, I'm gonna use a volume because this is all 3D content inside this content view. So I wanna display this inside a volume, which is essentially a bound container that lets you display a 3D scene. Now to do that, it's pretty simple. All you gotta do is change the window style of this window group. If you do that, and if you look at the options, there's plane, which is for 2D windows. There's volumetric. And when you choose volume, so now we're displaying content view inside of volume. The one final thing you need to do, if you go to info plist and go here, it says preferred default scene session role. This tells the system what scene to expect when the app first starts. Previously, we were showing a window when the app first starts, but now instead it's a volume, right? So you need to choose the starting scene here as a volumetric window scene application session role. So this guy here. So now we're telling the system, hey, when that first starts, we are going to be showing a volume, which is correct because that's exactly what we're doing here. We're showing a volume when the app first starts. Now, if you click build and run, you should see it all work. So let's try it on. Great. So now you can see there's a volume. So if you look at the base plate, the volume's clear and the bounce of the volume is also clear. That's the bounce. But now you can see the model's appearing as expected. With some animation, you can see the hands moving, so that's all working. But what's not working is it looks like something's getting clipped. Now, why is that? At the moment, we have a volume, and inside the volume, we're displaying a reality view. Now, the size of the reality view here is most likely the size of the volume, hence why the upper body is being clipped. You can see anything above this is being clipped, meaning the model's much larger than the reality view that contains it. To fix this, we can adjust it so that the reality view size would adapt to whatever the content inside is. So in this case, because Elion's bigger, reality view's size should match that, right? So that it won't be clipped. So to do that, we can go back to our code. So here, for reality view, you can collapse it. Inside content view, reality view, this is where we display Elion. So you can collapse this, and then there's a modifier called reality view layout behavior. This is a view modifier that controls the frame sizing and content alignment behavior for reality view. So this is what we want. If you look at the option called fix size, you can see the option that fixes the size of the frame to equal the size of the visual content inside it. What's happening here is when we choose this, reality view will first look at the size of the content inside it. So in this case, the Elion. So Elion is the content inside. Look at the size of Elion, and reality view will size itself to match Elion's size, so that it won't clip Elion in any way. So if you do that and try building and running, we should see that issue fixed. Great, so now you can see the reality view is much bigger. It has increased its size to match Elion's size, and hence Elion's not being clipped anymore. Because remember, there's a volume, and inside the volume there's a reality view, and inside the reality view is Elion. And because now the reality view and volume is bigger than Elion, it's not being clipped. Great, so that's great news, but we got two problems here still. One, we see these holes, right? Because Elion's animating, when it moves forward, it's probably moving beyond the bounds of the volume. If you imagine this is the size of the volume, when Elion's animation's moving forward, it slightly goes beyond the bounds of the volume, hence that content's being clipped as well. To fix that, we can adjust the volume in a way so that this clipping behavior won't be there. And furthermore, Elion looks a little too large for my liking, so I'm going to make him slightly smaller as well. So let's fix those two issues, these animation clipping and then the Elion size, make him a bit smaller. Now to fix the clipping bit, again, there's another modifier called preferred window clipping margins. This requests additional margins for drawing beyond the bounds of the window. So here we're saying, hey, we want content to be able to be rendered beyond the bounds of the volume. So we're saying, give us a bit more space to render the volume. So that will give essentially a bit more room for Elion to render and avoid that clipping behavior when he animates. And now finally, I'm going to make Elion a little smaller. So I'm going to go here, package, open Elion in Reality Composer Pro, click on him. And here you can see under transform, that's the scale property. So right now it's 111 across X, Y, Z. I'm going to half that and make it 0.5, 0.5, 0.5. Great. He's a bit smaller now, half his original size, and make sure you hit save. And now I'm going to go back and build this again. Now it should all be working fine. Great, so now you can see Elion's slightly smaller, not a lot smaller, but slightly smaller. And he looks reasonable in size. And you can see when he's animating, the face is not being clipped because again, we're giving a bit more margin for him to render inside the volume using that modifier that we used. Awesome, so that looks great. That's Elion ready. His body is ready, it's come to life, he's animating nice and smooth, and he's contained inside this nice little volume. So far, we got Elion's LLM-powered brain ready, we got his speech ready using the text-to-speech service class, and then now we got his body ready, rendered in a reality view inside a volume, nice and smooth. So we got the brain, the voice, and the body ready. So Elion himself is ready. Now the last thing we want to do is we want to connect the three different pieces together. So the brain, the voice, and the body. But before we do that, we also need to do one more thing in terms of the UI. And that is we need to have some way of communicating to Elion, right? So we need to get input from the user so he can communicate to Elion. So the ideal way to communicate to Elion would be through voice. It's through voice that we connect the most instead of through text. So to make it realistic, we're going to communicate to him through voice. So to do that, we're going to create a simple prompt UI here, which when we press will open up the Apple system speech to text converter. So we're not going to create our own speech to text framework here. It's going to take too much time. Instead, we're going to use the inbuilt speech to text functionality that comes with the onboard keyboard. So let's do that next. Great. So now to create the prompt UI, I'm going to create a new file. Choose new file from template, and I'm going to choose the Swift UI view here as a template, and then I'm going to name this prompt UI. And also to clean this a bit up, so I'm going to create a new folder, and I'm going to call this views, and inside here I'm going to drag the content view, which is the main view, and the prompt UI, just to make things a bit cleaner. Great, so now we're in the prompt UI file. And let's just also bring back the canvas so we can do some rapid prototyping. Great, so now we got the preview canvas, and this one we can use for rapid prototyping. At this moment, the prompt UI contains just simple text, hello world, as you can see at the center here. So I'm gonna get rid of that. And instead, I'm gonna first create an H stack, which would contain our prompt UI. And then I'm gonna give this a fixed size of 20, and then a height of say 36. And then we're gonna simply create two text in here for now, just to see what we have. Text hello, and then another text, say hello. Just to see it in the preview, two text placed next to each other because it's inside an H stack. So here, instead of this, I was just doing that just to make sure the H stack is working. I know it's not really necessary, but quickly here, I'm gonna give this H stack some glass background effect so we can see the background clearly and the frame size. Great, so that's looking good. So that's the H stack essentially, the prompt UI. The prompt UI contains an H stack with two text at the moment. So I'm gonna get rid of this text. Instead, I'm gonna have a text field here, and the text field would take in a title key. The title key would be the string that's displayed if there's no text in the text field. And here we want to prompt the user to enter some text. So we're going to say, enter your thoughts. And then there's also a text variable. This is essentially binding to a string. So this text variable would contain the text input that the user has inputted through the text field. And because this is a binding, what we're going to do is we're going to create a state variable here, state var, and we're going to call this prompt text. This would be a string, and we're going to initialize with an empty string. We're going to bind this input text from the user to the state var. So we're going to do $prompt text. That's how you bind a state var to a binding prompt text. Before I explain this, let's just see what we get in the preview. Let's just run this again. Great, so now you can see the preview, we get this H stack, which just contains a text field and is prompting the user to enter some thoughts. What happens is, because this is a text field, when I click on this, the system keyboard appears. If you go back here, you see the system keyboard appears. And when I type on the system keyboard, just press on some random letters, you can see that text field contains that text, right? This would be the input from the user. And this input is what essentially gets passed on here in this text binding var. And that one, we're binding it to the state var so that we can get access to the user input text using the state var. So this guy here is what would contain the user input, this string here. What we can also do is use this like speech bubble. You can see this guy here. And if you click on that, what that lets you do is it lets you speak, and Apple's own native speech to text conversion framework would essentially convert that into text and again display that in the text field. So this gives you some speech to text functionality for free. And that's what we're going to leverage here. We're not going to build our own speech to text framework here because it's going to take some time. Instead, we'll just use the one that's inbuilt with the native keyboard, which we get access through the text field. Great. So simply either way, whether they type through the keyboard or speak through the speech bubble, either way, that text would be stored in the text field and we get access to that here, and we're going to store that here. Great. So that's the base done. But obviously this UI in itself doesn't look good at the moment. So we're going to design and polish this a bit. So the reason I put this inside an H stack is so that I can add an icon right to the left of the text field. So for the icon, I'm going to use an SF symbol, and that SF symbol is going to be sparkles. And if you're not familiar with SF symbols, these are natively provided symbols that Apple provides for you. All you got to know is the name of that SF symbol, which you can get from the symbol library, and that name for this specific icon. So this guy here, this icon is called sparkles, hence why I created an image with system name sparkles. This would give us access to the SF symbol for this. And then I've given a secondary foreground style. Great, so now inside this H stack, we've got first the sparkles and then the text field for entering the text. The sparkles would imply intelligence and gets it the whole AI vibe. Great, so that looks a bit better, but obviously we can add some padding around the H stack so that this is not just too hugged to the corners. So to do that, I'm simply going to create some padding around the H stack. So padding across all edges, I'm going to give a padding of 10. Let's see what that gives. Great, that looks a lot better, right? It looks slick and clean and minimalistic. All the user got to do is press on the text field and enter in the text either through the keyboard or through the speech bubble by speaking, and then that text would be stored here. Great, so we got the prompt UI ready. Now the only problem is this is a separate component in itself, and we have no way of passing this prompt text outside to the content view. Because later on when we tie all this together, we want to be able to pass this text outside so that we could essentially pass this prompt text to the AI model, right? The LLM service. So to do that, what we're going to do is there's a modifier called onSubmit. Again, this closure would get called when the user finishes inputting text to the text field and presses enter or return, right? So when the interaction with the text field is finished, this guy would get called. And what we can do here is we can essentially pass the prompt text, so the final user input text, to whoever needs it. So to pass things around, obviously we'll use closures. So closures are functions which you can pass around. If you don't know, I'm going to create this closure called, name that submit. And this closure is going to take input of string and it's going to return nothing, so void. And now the preview is complaining because we added a closure as a property. So we need to pass this as an argument. And here for the onSubmit bit, I'm going to create an empty closure and ignore the input like that. Great. That will silence the error. And now what we can do here is coming back to the original plan here when the user has finished interaction with this text field. So onSubmit, in here, we're going to call the onSubmit closure. To do that, we simply do onSubmit, and then as the input, we'll pass in the prompt text. So what happens here is when the user finishes interaction with the text field, this onSubmit closure gets called. In that closure, we'll pass in the prompt text. So whoever needs this gets access to it. Oh, again, you'll see this in action when we tie all these things together. But essentially, right now, we got everything we need in place. We got the prompt UI, which lets the user speak to the AI. And then we got Elion's body, brain, and speech ready. Now it's time to tie them all into one and connect everything up together. So let's do that next. Great, so now to connect everything up together, Elion's brain, body, voice, and the prompt UI. So to connect all these different pieces together, what we're going to do is we're going to use a view model. So if you're not familiar with the MVVM architecture, the MVVM architecture has the models, which is all the business logic. For example, in our case is the brain and the speech service, these two guys here. So that's the model in M. And then there's view, which is the user-facing views. In our case, the content view, which displays the 3D scene, and the prompt UI, which we'll soon place here. And then there's a view model. That's what the last VM stands for, MVVM. Now the view model is what essentially sits in the middle between the view and the models. And the view model talks to the models, so the services, and then it also gives information to the view that it needs to display. So the view model sits between the view and the models and essentially glues both of them together. That's MVVM, model, view, view model architecture. And it's one of the most popular architecture used these days, even in industry applications. In my company, we use MVVM, and I've seen in many other companies, they do the same. So we're going to use the same architecture, although for a very prototypey project. Here, what we're going to do is create a view model that will essentially talk to the services as needed to display whatever we need here. So let's first create the view model, and in there, we'll glue everything up together so that the brain, the speech, and the body all talk to each other nicely. So for that, I'm going to create a new folder. I'm going to call that view model. So now you can see it follows the MVVM architecture, right? So there's the model, view, and the view model. And inside the view model, I'm going to create a new file. It's going to be a Swift file, and I'm going to name this content view model. So this would be the view model for this file here. So for this view. And in here will contain all the gluing logic that would talk to the brain, the body, and the voice together. Great, so this is going to be a class content view model. And this view model, it will have essentially one simple function, right? It's going to have one simple function called respond to prompt. And the prompt would be passed in as a text. So prompt would be a string. And then inside this view model, what we're going to do first is use the brain, Elion's brains, to process the prompt and generate a response. And then we're going to use Elion's voice to convert the response to speech. So the brain gets the raw user input, gives us an output in the form of a text, and this guy here would convert that text to speech. Again, we've got all the logic for that designed within these services, the LLM service for the brain and the text-to-speech service for the voice. So now what we're going to do is we need to use those services here. So let LLM service. This would be of type LLM service, the class we created for the brain. And similarly, we want a text-to-speech service, right? To text-to-speech service, and that would be this guy here. And now we can create the constructor where we'll pass in the LLM service and the text-to-speech service. And when we construct this class passing in these two services, those would be assigned to these variables. Essentially, we'll initialize this class with these two services ready. So whenever this class gets created, these two guys would be ready because we'll be passing them in here. Now, just to make things simpler, we're just going to initialize this here itself. So I'm going to create an LLM service here. I'll just make this a bit more cleaner and easier to read. So if I separate that into a new line and text-to-space service as a new line. So here, essentially, we're just constructing this LLM service inline. So I'm using init. And that LLM service, if you remember, if you go into it, you can see it requires a language model session. So we need to pass one to it. So to use the language model session, we need the foundation framework. Again, that's the foundation models. That's the AI framework for Apple. And now we can create a language model session and pass it in instructions. And the instruction, which gives it the personality, we already created it as an extension to string, and it's called model instruction. So it's going to be string.model instructions. Again, if I break this down into separate lines, just so it reads nicer. Great, so that looks a bit better. Awesome. So that's the LLM service constructed inline. And then we got the text-to-speech service. Similarly, what we're going to do is we're going to initialize it inline. Now here, to construct a text-to-speech service, if you go to that service class, we need to pass in an AB speech synthesizer, right, when we create it. So we're going to go back to the content view model. And when we create this, and for the speech synthesizer, again, to create that, you need to import the AB foundation framework here. So AB foundation, and now we can simply call init to create a fresh instance of an AB speech synthesizer. Great. Now if that confused you, don't worry, it's very simple. Basically, this view model needs access to both Illion's brain and voice, right? So the LLM service and the text-to-speech service. So we added them as properties here for this class, which means when this class gets constructed, this needs to be there. And in the constructor, we pass in the LLM service and the speech service as an input parameter, and then we just construct them inline like that. It's simple as that, nothing complicated. And if you're a complete beginner to programming and the Swift way of constructing things confused you, again, just chat GPT a few things and you'll understand what's going on here. But basically, at this point, what this means is when the view model is constructed, when we create the view model from outside, essentially it would have an instance of both the LLM service and the text-to-speech service. And now we can use the LLM and text-to-speech services to essentially do the main bit, which is essentially responding to the user prompt. And the way we're going to do that is simple. So here, we're going to use the LLM service. And remember, the LLM service has a response to function, which we created earlier. And that essentially takes the input, the string, the user's input, and it outputs a string as well, which is an optional. So the input would be the user prompt and the output would be the AI model's output. So the user prompt input here would be the prompt that's passed into this function. So we're just going to pass that here, prompt. And the output, we're going to store this here. We're going to call this AI output. And because this is an asynchronous function, what we need to do is prefix this with await, because the AI will take some time to respond, right? So that's why this is an asynchronous function. So we're going to prefix that with await. And also we're going to wrap all of this inside a task so that this sits inside an asynchronous context. Great. Now that should work. So that's how we run an asynchronous function. We have a task which runs an asynchronous function, and then we got the response to function from the brain, and we're awaiting that. And when the brain has finished processing that input, it will store that here, and then it will move on to the next line. The next line, what we want to do is essentially use the text-to-speech service here to essentially convert this text into speech. And for that, it's quite simple. All we're going to do is we're going to use text-to-speech service dot speak. Again, if we go into the text-to-speech service class, that's a function we created earlier to essentially convert text that's passed here into speech. Again, all that is created already. So if we go back to the content view model, inside here, all we need to pass is pass in the output text from the AI. So like that. And now we're getting an error because saying this is an optional. So because this is an optional, we need to unwrap that. So I'm going to do guard let output text. If there is an output text, great. But if there's no output text, so else, then simply return, i.e. the rest won't be executed. But if the AI gives us output text, we pass it to the speech service, which will essentially convert that to audio. So the user gives them some prompt, and that prompt passes through the AI's brain and then gets converted to voice. So like the human body, right? The brain produces some output, and through our mouth, those words come out. So here the brain is giving us an output, and the mouth is speaking that output out. Pretty cool, right? So that's a clean way of organizing our code. It makes it so much more readable. We know everything to do with the brain is here, everything to do with the voice is here, and we're gluing them up all together inside this view model. Great, so now we got this view model, which contains this respond to prompt function. Simply calling this function with the prompt text will result when Elion responding in audio format, the response to this prompt. So you pass in the prompt and Elion responds in audio. Now all we got to do is call this from somewhere. Now to do that, I'm going to go back to our views. I'm going to go back to our content view. And right now we simply have this reality view, which displays Elion. Now what we're going to do is we're going to have Elion, and then on top of Elion, we're going to have the prompt UI. And when the user finishes typing in text through the prompt UI, we would then call that function from the view model. So let's modify the UI first. So I'm going to copy this 3D scene code, the reality view code, and then I'm going to put that inside a VStack layout. So VStack layout is a new layout that came with visionOS 26. It's like a VStack in Swift, which lets you place things on top of each other, vertically laid out. But the difference here is this is more for laying out 3D content. For example, it gives you things like the depth alignment to align the models inside this VStack based on its depth. But we'll come back to that later. For now, I'm simply going to paste in the 3D scene here, the reality view. So this is the 3D bit. And then on top of the reality view will be the prompt UI. So prompt UI with the onSubmit closure. And onSubmit closure returns to us a string, which would be the prompt text. Or let's just call this user input text, user prompt text. So this would be the text that the user has inputted in the text field, either through voice or the keyboard. And then it runs this closure. So this closure is essentially what gets executed when the user has finished typing in the text, and that text we get through this variable here, which we pass through the closure. Great, awesome. To recap, here we got a VStack layout where we first showed the prompt UI, and below that is the reality view, which shows Elion. And in this prompt view, we got this onSubmit closure, which gives us the user prompt text, the text the user has inputted. So here, what we can do is when the user has submitted the text by returning the text field, we can then pass that to the view model's respond to function, right? So what we can do is create the view model here. So let view model, this is typical MVVM. The view has just access to the view model, and the view model handles all interactions with the business logic, like the service guys. So here the view simply knows the view model. And then here, when the user has finished submitting the text, we use the view model and call its respond to prompt function that we just assigned. And for the prompt, which is a string, we'll just pass in this user prompt text, which is essentially the prompt that the user has given us. Great, awesome. So simply calling this function like this will run the whole pipeline so that Elion will start responding to us using speech. Great, so that's that. And I'm going to add a bit of spacing between the prompt UI and the 3D Elion. So I'm going to add some spacing of 20. Great, so now if we build this and run, let's see what we get. Great, so now you can see there's Elion and the prompt UI just above him. But you can see the prompt UI is not that visible. The prompt UI is very small compared to Elion, so we might need to adjust the size of the prompt UI or simply adjust the size of Elion. We'll do that later, but first let's just see if the core functionality is working. I'm going to hit the text field, and then this is going to pop up this guy here, the keyboard. And here, once I press on the speech bubble, I can start talking through. My audio will get captured and converted to text here. So I'm going to do that. And I'm going to ask it the question, what is the meaning of life? Let's see what we get. So I'm going to click on, what is the meaning of life? Great. And now that text is here. So as soon as it returns, now the onSubmit closure would get called, and Elion is processing at the moment. And it will take a while, and then it will respond to us.
To ask about the meaning of life is akin to gazing upon the cosmos and wondering about the whispers of the universe itself. Life, dear traveler, is a journey, an odyssey through the silent expanses of time.
Awesome, so now you can see Elion is responding to us, right? We asked it what's the meaning of life. It gave us a nice solid response. The brain, the voice, and the prompt UI, it's all connected together. We brought Elion to life. And now all we have left to do is simply to add some polish, right? So first thing, you can see the prompt UI is very small compared to Elion. So we're going to make Elion slightly smaller. And then we'll also give some user feedback, right? Because right now it's just the idle animation playing throughout. But remember, we have animations for talking and also for idle and also for thinking. So we're going to make use of these three animations so that when Elion starts thinking, we're going to play a thinking animation so the user knows that Elion's thinking. And then when Elion starts talking, we're going to start the talking animation. And then finally, when Elion's finished talking, we're going to revert back to the idle animation. So we're going to add some logic around that so we can add some nice polish to this experience. And once that's done, Elion will be fully ready to be experienced and we're going to unleash him to the world. So it's exciting times. We're getting very close and let's see what we get. Great. So now if I go to the content view and if I collapse everything by doing Command, Option, and left arrow, that will collapse everything. And now you can see in the content view, we got here the body, which essentially lays out all the 3D stuff. And here we got some extension to the entity class, right? And here we already had a play animation function, which essentially plays the animation for us based on a name we give it. So for example, in the reality view, here we got the Elion entity, which we load from Reality Composer Pro. And then we call the play animation function and we provide there the name of the animation that we want to play. In this case, Elion idle. And that would essentially play the Elion idle animation on this model. And this function, again, is something that we created here as an extension of entity, right? We wrote the code for this before. So all we got to do is essentially provide the name of the animation that we want to play as seen in the animation library for that entity. For example, if you go to your Reality Composer Pro project, and here as a reminder, if you click on Elion, you can see Elion has an animation library component. And in here, it has multiple animations, right? There's one Elion idle, which is what we currently play. And then there's one called Elion talking and then Elion thinking. So Elion idle is the idle animation. So if I zoom in, you can see he's idle. And then Elion talking, this would be the talking animation. This is what we want to play when Elion starts talking. And then there's the thinking animation. And this is what we want to play when Elion's thinking, i.e. when the AI model is at work in generating the response to the user prompt. Great, so these three animation, just note their names because that's what we want to play using that play animation function that we created earlier. Again, remember that play animation function plays the animation stored within the animation library component of the entity. And in this case, Elion has the animation library component and it has these various animations. So all we got to do is provide the name to play it at the right spots. So the first thing we're going to do to make things clean and easy, we're going to go to the content view model and here I'm going to create a new enum and this enum is going to be called character state. So this would be the state of Elion, right? Whether he's thinking, idle, or speaking. And by the way, this enum will have an underlying string value. And for case idle, the underlying string value would be essentially the name of the animation that we need to play when the Elion's idle. When we come to use this, it will all make sense. But the name of the animation when Elion's idle is called Elion idle. So just make sure you copy that exactly and then paste that here. That's correct. And now the other case would be Elion thinking. And in this case, we want to be this guy here. So copy that exactly and paste that here. Elion thinking. That's correct. Now finally, we want case speaking. And this would be Elion speaking. Just make sure that's correct. So if you go here, actually that's wrong. So just make sure you are taking the Elion talking string and copy that and paste that exactly here. This enum we'll use soon to essentially determine whether it's Elion's idle, thinking, or speaking. And each of these cases would have the underlying string value, and that underlying string value would be the name of the animation. Actually, a more accurate name for this enum would be animation state. So let's rename this to animation state. That would be more accurate. Idle, thinking, speaking. That's correct. Now what we can do is inside this view model, we can have what you call a published property. So published var, and this property, we're going to name this animation state. And this would be of type animation state, the enum that we just created, and the default animation would be idle. And the reason why we mark this as published property is because anytime this guy changes, for example, if some function here changes the state here, anytime that changes, the view, when it listens to a published property, it can react to the state change, right? So if the animation turned from idle to moving, then the view would react automatically as long as it's bound correctly and glued correctly to the view. On a high level, remember in MVVM, the view model essentially contains a logic that would talk to the different services and the models in the app. And the view model would also contain these state variables, like these published properties, which the view would listen to and react to. Anytime these state variables change, the view can essentially automatically react and re-render the UI with the updated state. So the view reacts to the app state, and the various states of the app are stored in the view model using this property wrapper called published. To make this work, we need to make sure this class is an observable object now, which means the view can observe changes to it. For example, changes to anything marked with published. The view can now observe changes to it. And now if we go back to our view, we also need to make one more change. When we create the view model here, we need to make sure we change this from a let to a var and prefix that with a state object. And now we can essentially observe values in this view model that are published. And anytime we bind that somewhere here, that part of the view would re-render and essentially react to state changes in the view model. Again, the view model contains the app state. Again, if all of that confused you and if you're a complete beginner to this, don't worry. As we code along, it'll make sense. But essentially in this content view model, we created this new animation state, which would essentially control the animation of Leon. And you'll see how as we write some glue code for this. So the animation state has three cases: idle, thinking, and speaking. And each of these has an underlying string value, which maps exactly to the animation name in Reality Composer Pro. So now what we want to do is essentially change this state based on whether Elion's thinking, speaking, or idle, right? For that, again, remember all the processing happens inside this function, right? When this guy gets called. And this guy gets called, the brain is put to work, and then the voice is put to work once the brain output is ready. So what we want to do is just before the brain starts processing the user input, so just before Elion starts thinking, we're going to set animation state to thinking. And then he thinks and takes a while to think, and all the while the thinking animation will be playing. And then once he's finished thinking, i.e. we got a response, we get the output as the AI output text, and we pass that to the speak guy here. So the speech service, and that will start speaking out the text. And at that point, once it starts speaking out, we need to change this animation state to speaking. So here, when this guy is called, first Elion starts thinking, so the animation state set to thinking. And then we await on Elion to finish his response, finish thinking. And then once we finish thinking, he gets the output text, which then gets passed to the speech service to speak it out loud. And while he's speaking, the animation state would start speaking. And also here, if there's no output text available from the AI, he should stop thinking, and then we should reset the animation state to idle. Great. So inside this function, again, the state variable, the animation state guy, is changed to idle, speaking, or thinking based on Elion's actual state, whether he's thinking or speaking. Now, all we got to do is make sure the view listens to this state and plays the animation correctly. So for that, we're going to go back to the content view. And what we can do here is under the reality view, we can use this modifier called onReceive. Again, this adds an action to perform when this view detects data emitted by the given publisher. Remember, we have a publish property in the view model, which is essentially the animation state. So we can observe changes to that using this onReceive guy here. So we can do like view model dot animation state. And then this would give us the output disclosure, the current state, and then we can execute some code here. And this function passes us the current state, the animation state, which it changed to. So here we can simply use the play animation function and pass in the name of this current animation. So here we can just simply change this to current animation state to be more accurate. And remember the current animation state, this guy here has this raw value, which is a string. And this string value, if we go back to our view model again, this string value is again literally the animation name that we want to play. So that's why we had these underlying values for these enum cases. So here all we got to do is pass in this guy here, the raw value of the animation state, the current animation state, to this play animation function. And this would essentially take care of playing the animation. Hope that makes sense. Great. So now obviously this play animation function is an extension to an entity. So we need access to Elion, right? Right now in this make closure, we store Elion in this variable and add it here and then play the animation here. Elion scope is just within this main function, but we want a bit more global scope. So we could call this play animation function within this method as well. What we can do is move Elion here by creating a state var Elion, which is of type entity. And this would be an optional. And here what we're doing is when we load the model from the RCP, we store that inside this Elion entity that we just defined here. Now, because this is an optional, we need to make sure before we pass that to the content view, we need to unwrap it. So just before that, we're going to do guard let Elion. If it exists, great. Else we simply return. So this is the same as saying, if it exists, great, store it in this variable, and then pass that here. And then if it doesn't, it will simply return. Great, so we're just unwrapping that optional here. So that all the error is gone now. Great, so now we move the scope of Elion beyond this make function, and it's stored here so that anything within the struct could use it. So Elion, as soon as it gets created, it gets stored in this variable. And then this onReceive function now, whenever there's a new animation state, what we can do is use Elion. This is the entity that we want to play the animation on. And then if we click the play animation function that we just created earlier, so this guy here, and then for the string, we're going to pass current animation state dot raw value. Remember, the raw value of the animation state is the exact animation name that we want to play. So this would work. Again, go back to the view model. Remember the animation state, the raw value is the exact animation name that maps to the ones in Reality Composer Pro. Great, so all we're doing here is in the view model, we got this animation state, which essentially changes when it starts thinking and speaking. And whenever we detect a change in the state, we simply play whatever animation Elion's supposed to be in at that point in time. For example, when he starts thinking, this would change to Elion thinking, and the thinking animation would play. When he starts speaking, this would change to Elion speaking as a string, and the speaking animation would play. Great, now the animation bits should be working. So let's test this out by building this and running. So we got here, as usual, he's a bit too large compared to the size of the prompt UI, but again, we'll fix that soon, so don't worry. But right now I'm going to click on the text field, and here for the text, I'm going to pass in a text, say, what is the meaning of life again? And let's say return. And now you can see as soon as he starts thinking, the thinking animation's playing. Again, we'll fix that clipping behavior as well soon. And now when he's finished thinking, he will soon start the speaking animation.
Others live the cosmos, and when there are those who speak of finding solace in the shared silence between worlds. Yet, dear seeker, the meaning of life is not to say.
Great, so now the Elion has finished speaking, but you notice one thing, right? When he's finished speaking, the speaking animation still play. That's a bug. We want to fix that because when he finished speaking, we want to make sure he's idle again. So what we want to do is actually detect when he's finished speaking and then change the animation state to idle. If you go back to our code now, and if you go to the view model, what you notice is here, when the respond to prompt function is called, we set the animation state to thinking, and then when it starts speaking, we set to speaking, but nowhere do we set it back to idle, right? And when do we want to set it back to idle? When he's finished speaking. Right now, we don't have any code to detect when Elion's finished speaking. For that, let's go to text-to-speech service and let's add some code here. Thankfully, the AV speech synthesizer comes with a delegate method that notifies us when the speech has been finished. And that's something we can hook into. So thankfully, there's APIs for this, so it's not too complicated. I'm going to create an extension to this class, extension text-to-speech service. And here, I'm going to use the AV speech synthesizer delegate. You can see this is a delegate protocol that contains optional method you can implement to respond to events that occur during speech synthesis. If you autocomplete, you can see these are various methods. You can see there's did pause, did start, did cancel, did finish. This tells the delegate when the synthesizer finishes speaking an utterance. That's exactly what we want. So this delegate method notifies us when Elion has finished speaking. This is something that again comes with the framework. We don't need to do much here. So all we need to do here is when it's finished speaking, we can set the character state to idle. Now we get an error saying cannot declare conformance to NS object protocol in Swift. Text-to-speech service should inherit NS object instead. So to fix this, we can just make sure this class text-to-speech service inherits from NS object. That error should be gone. Awesome. Remember, this is an extension to this class, so it's the same thing. Just to write code cleaner and more readable, we're separating out the delegate methods into an extension here. Awesome. Now we need to do one more thing. Make sure the initializer to this class, for the speech synthesizer, we need to make sure we set the delegate to self. So make sure you do that. I always forget to do that. And oh, forgot the self here. Self dot, yeah, great. So before this, you do a super init as well. Great. So now essentially the delegate for the synthesizer would be this class, and hence whenever the speech is finished, this method would get called. But just by doing that, whenever this speech finishes, this guy would get called, and we can essentially know Elion has finished speaking. Now, obviously, after he's finished speaking, what we want to do is change the animation state to idle, right? We can't change the animation state to idle because the animation state is contained within the view model. So we need to essentially notify the view model from here when this function gets called that the speech has finished. So for that, I'm going to use some more combined stuff. So I'm going to create this finished speaking pass-through subject. So this would be a pass-through subject with void and never as the generic types. Void and never. And then for this to work, we need to make sure we import combine. And then what we can do is when the speech has finished, so when this guy gets called, we can do simply finish speaking dot send. And now what we can do is from the view model, we can subscribe to this finished speaking guy. So this is the publisher subscriber pattern. So here what we're doing is when this guy gets called, we're publishing an event. So we're sending one. And then what we can do is from the view model, we can subscribe to that event to observe any changes to that pass-through subject. So here in the view model, because we already have access to the text-to-speech service here, so what we can do is simply when the view is first constructed inside the constructor, we can add the observer here, be notified when speech ends. So the way we do that is inside the text-to-speech service instance here. Again, we just created that finished speaking publisher, the pass-through subject. So we can observe changes to this by simply doing receive, and we want to receive on the main thread. So we're going to do dispatch queue.main here, and then do a sync. And this gives us the value, and we can ignore the value here. So we're just going to do a weak self here, capture the self here, and the code here. So ignore all this boilerplate code. I'm not going to bother explaining that. We can go into another rabbit hole there. But all you got to know is this closure would get called when the speech ends. How do we do that? Back in the text-to-speech service, we got this guy here. And whenever this delegate method gets called, we trigger an event, we publish a value. And then when that happens, we get notified here in the view model. So this is essentially one way to communicate between classes. There are various different ways, for example, closures or callbacks, but we're not going to go into those. But here we're simply using the combined publisher subscribers to essentially publish from the service, text-to-speech service, when the speech has finished. And we observe that the view model here using the sync guy here. So we're subscribing to changes there. So here is what gets called when the speech finishes. So when the speech finishes, all we got to do is change the animation state within self. So self is the content view model here, and the animation state is this publish property that controls Elion's animation. And we're going to set the animation to idle, simply like that. Awesome. One more thing, when we use combine publishers and subscribers, there's some more glue code. So we need to make sure we create a cancelable here. So I'm going to create a private cancelable. So that's autocomplete like that. And then once I do a sync here, I'm going to make sure I store this inside the cancelables. Great. Awesome. So that's all the glue code done. Forget all the boilerplate code. All you got to remember is when this guy would get called when the user finishes speaking. When that happens, back in the view model, this guy gets called. And in here, when the speech finishes, we set the animation state to idle. And then Elion would automatically be idle. Awesome. Great. So now before we build and run, we're going to do one last thing, and that's to make sure Elion's a bit smaller. So what I'm going to do is scale down his size from 0.5 to 0.1 like that. So that's much smaller. And now I'm going to make sure I save this as well. So save. Now you can see Elion's much smaller here back in Xcode. That's great. And now let's build and run. Let's see what we get. Awesome. So now you can see Elion's much smaller and it looks a lot more better. And the prompt UI looks decent in size. Obviously, you can tweak around the values and play with Elion's size or the prompt UI size to get the best fit that you would like. But I'm going to stick with it as this looks good to me personally. Now I'm going to ask it some questions and let's see what we get. And hopefully when he finishes speaking, the animation would revert back to this idle animation. So I'm going to ask it some questions now. Tell me about the origins of the universe.
It was the Big Bang, a moment both subtle and grand, where the very fabric of reality stretched and curved into existence. In this grand cosmic narrative, each of us is a note in the symphony of existence, a fleeting yet precious moment in the eternal song of the universe.
Awesome, so now you can see Elion has finished speaking some profound thoughts, and he has told us a bit about the origins of the universe, and you can see when he finished speaking, we revert back to the idle animation. So that all looks great. Obviously, you can fine-tune this and tweak it as much as you like, but for me, this looks fine, and we've finished with the Elion experience. That's pretty amazing, right? We've essentially created digital artificial life here that we can speak to normally as we would speak to a human. It has embodied within it some intelligence using Apple's on-device LLM, And we used the foundational model framework for that. And we also gave it some personality by feeding it some instruction file, which it listens to before it listens to the user's prompt. So that way we got some AI in here that has some personality. And then we gave it some voice by converting AI's output into audio using Apple's AV Foundation framework. And then we connected all that bit up, the body, the voice, and the brain together in a view model, which then this reality view listens to and reacts to. Hope that all made sense. We covered a lot of things in this video and hope some of that was useful to you. So that's it, and I'll see you soon.